In this module, you will be introduced to the automatic flight control system of the ATR 72-500. We will start out with a brief system description. Next, we will look at the individual components of the system, starting with the autopilot and yaw damper systems. Next, we will look at the flight director system. Following the flight director system, we will look at the different vertical and lateral modes of the AFCS system. Finally, we will look at the altitude alert function of the automatic flight control system. The ATR 72-500 is equipped with an autopilot system that can control the aircraft about all three axes. In addition to the autopilot functions, the automatic flight control system also provides yaw dampening functions. In addition, the system also drives the flight director system as well as provide altitude alerts. The automatic flight control system, or AFCS, consists of one computer, a control panel, an advisory display unit, or ADU, and the three servo actuators. The AFCS computer incorporates two microprocessors in order to provide system redundancy. The computer is powered by the DC emergency bus. The AFCS control panel is used to engage or disengage the autopilot. It is also used to engage the yaw damper as well as select the desired operating mode of the flight director or autopilot system. The AFCS control panel is located on the glare shield. The advisory display unit, or ADU, is also located on the glare shield immediately above the AFCS control panel. The ADU displays advisory and caution messages and is used by maintenance to perform tests on the autopilot system. The ADU is powered by the DC standby bus. The AFCS computer receives data from the two air data computers, the two attitude and heading reference systems, the two signal generator units, the radio altimeter, and other sensors. If the aircraft is equipped with a GPS unit, that GPS will also provide inputs into the AFCS computer. Since there are dual AHRS and ADC inputs, the values from each system are averaged. Based on the data supplied, the AFCS computer generates commands which are then fed to the flight director system and the autopilot servos. Flight director commands are displayed on the EADI. The AutoFlight flight control system uses three servo actuators to control the aircraft. These consist of an electric motor and a clutch assembly that moves the respective flight control surface. The pitch and yaw actuators are located in the aft portion of the aircraft. The roll servo actuators are located on the aft side of the wing box. The control for the servos is powered by the DC standby bus. Autopilot inputs into the roll axis are made through a roll servo actuator which uses a cable and drum assembly to control the roll axis. Inputs made by the autopilot are reflected on the control wheels. Autopilot inputs into the pitch axis are made through a similar servo actuator which drives a cable and drum assembly. The autopilot makes trim inputs in the pitch axis only, and they are reflected on the control column. The autopilot does not control the trim actuators for aileron and rudder. The pilot must control those inputs in order to maintain coordinated flight, as well as minimize load on the servo actuators. A yaw servo actuator also uses a cable and drum assembly to make inputs to the yaw axis. The yaw damper provides yaw damping and turn coordination functions. The AFCS computer uses the autopilot yaw actuator to transmit the necessary yaw damping and turn coordination commands. The autopilot is engaged by pressing the autopilot push button on the AFCS control panel. When the autopilot is engaged, it will also automatically engage the yaw damper. Engagement of the autopilot and yaw damper is indicated by the illumination of the arrows on each side of the autopilot and yaw damper push buttons. If the autopilot is engaged, it can be disengaged by pressing the autopilot push button a second time. However, this action will only disengage the autopilot and the yaw damper will remain engaged. the autopilot can also be disengaged with the red autopilot disconnect button on the control wheel. The yaw damper can be engaged or disengaged independently of the autopilot by means of the yaw damper push button. The two arrows on the side of the push button illuminate when the yaw damper is engaged. If the autopilot is engaged, it will automatically disengage if the yaw damper is disengaged by pressing the yaw damper button. Once the autopilot is engaged, it will control the aircraft through the servo actuators. In addition, the autopilot will also automatically trim pitch through the pitch auto trim function. If no vertical and lateral modes are selected on the AFCS control panel, the autopilot will engage in the basic mode. The basic autopilot engagement mode is pitch and heading. In the basic mode, the autopilot will maintain the pitch that existed at the time of engagement. In addition, the autopilot will automatically level the wings and maintain the heading at the time the wings are leveled. If the wings are already level at the time of autopilot engagement, the autopilot will maintain the heading existing at the time of autopilot engagement. If a vertical and lateral flight director mode are active when the autopilot is engaged, the autopilot will immediately maneuver to follow the active commands. If vertical and lateral flight director modes are armed but not yet active when the autopilot is engaged, the autopilot will remain in the basic mode until the flight director modes are active, at which time the autopilot will immediately maneuver to follow the active commands. It should be noted that if a lateral mode is selected and no vertical mode is selected, the autopilot will engage in the active lateral mode but will remain in the basic vertical mode. The same holds true for an active vertical mode and no selected lateral mode. The lateral and vertical modes are selected on the autopilot control panel. The vertical modes are selected by the three vertical mode push buttons labeled Indicated Airspeed, Vertical Speed, and Altitude Hold. The vertical speed mode is selected by pressing the vertical speed push button. Once selected, the vertical speed can be changed by means of the pitch wheel. The lateral modes are selected by the push buttons on the left side of the control panel. These push buttons are labeled Heading, Navigation, Approach, and Back Course. The bank angle used for the heading select mode can be adjusted by the bank push button. Pressing the bank push button will change the maximum bank angle between 27 degrees and 15 degrees. Each additional push of the push button cycles between these two values. At initial system power-up, the maximum bank angle is set at 27 degrees. The autopilot can be disengaged either manually or automatically. The autopilot can be manually disengaged by using the quick disconnect push button on the outboard horn of each control wheel, using pitch trim, either normal pitch trim or standby pitch trim, pressing the autopilot push button on the autopilot control panel, pressing the yaw damper push button on the control panel, using one of the go-around buttons on the power levers, or by applying a force on either the rudder pedals or the control column. If the autopilot is manually disengaged, the yaw damper will remain engaged unless the autopilot is disengaged by using the yaw damper push button or by applying a force on either set of rudder pedals. A manual disengagement of the autopilot is indicated by the illumination of the red autopilot off light, and a cavalry charge will sound. In addition, the arrows adjacent to the autopilot push button will extinguish. In addition, the reset push button illuminates on the advisory display unit, and the second line of the display will indicate an amber autopilot disengage message. If the yaw damper has also disengaged, the two arrows on either side of the yaw damper push button will extinguish as well. The message on the advisory display unit will be different in that it will display an autopilot yaw damper disengaged message instead. The autopilot disengagement warnings and message can be cleared by pressing the reset push button or by pressing the quick autopilot disconnect buttons on either control wheel. If engaged, the autopilot will automatically disengage in the event one of the engagement conditions for the autopilot or yaw damper no longer exists, the stall warning threshold has been reached, there is a disagreement between the two AHRS or the two ADCs, or there is a mismatch between the two pitch trim commands. The indications of an automatic autopilot disengagement are the same as the manual disengagement, except that the autopilot off and the ADU messages are flashing. The warnings and message are cleared the same way. Click on the Start Simulation button to see an automatic disengagement. A pitch trim fail, pitch mistrim, or aileron mistrim message on the advisory display unit indicates a system failure. In this case, the crew's only option is to disengage the autopilot and hand fly the aircraft for the remainder of the flight. If the pitch trim asymmetry light illuminates on the center flight instruments panel, the autopilot will automatically disengage and cannot be re-engaged. If the autopilot or yaw damper disengaged due to a fault, the affected system can be re-engaged by pressing the reset button. However, if the cause of the disengagement still exists, the autopilot or yaw damper will disengage again. Certain conditions will prevent the re-engagement of the autopilot or yaw damper. These conditions are autopilot or yaw damper failure, trim inoperative monitor failures, failure of the AFCS control panel, any approach mode was selected at the time of the failure, the go-around mode was selected at the time of the failure, or the localizer or back course was selected at the time of the failure. The autopilot can be operated in the Touch Control Steering Mode, or TCS. In the Touch Control Steering Mode, the pilot can manually change the aircraft's attitude, altitude, vertical speed, and/or airspeed without disengaging the autopilot. The TCS mode is entered while the autopilot is engaged by pressing and holding the TCS push button on the outboard horn of either control wheel. If the TCS push button is pressed while the autopilot is engaged in the basic mode, the pilot can maneuver the aircraft and reset the autopilot's pitch and roll references. When the TCS push button is released, the autopilot will use the references existing at the time the button was released. There are some limitations to this reference reset. The pitch angle must be within plus or minus 15 degrees at the time the TCS push button is released. If the pitch exceeds these values at the time of the push button release, the autopilot will automatically reset the pitch reference to plus or minus 15 degrees. If the aircraft's roll angle at the time the TCS button is released is less than 6 degrees, the autopilot will automatically return to wings level. If the aircraft's roll angle is between 35 and 6 degrees at the time the TCS button is released, the autopilot will use the new roll angle as the reference. If the aircraft's roll angle is above 35 at the time the TCS button is released, the autopilot will automatically roll the aircraft back to 35 degrees of bank and maintain that roll angle. If the autopilot is in the altitude hold mode, the vertical speed mode, or the indicated airspeed mode when the TCS button is pressed, the pilot will be able to resynchronize the command references without disengaging the mode. The commands from the AFCS can be displayed on the EADI through Flight Director bars. This part of the AFCS system is called the Flight Director system. The Flight Director bars consist of a vertical bar for the lateral mode and a horizontal bar for the vertical mode. A Flight Director command bar is visible only if an associated mode is selected. For example, if a lateral mode is selected, but there are no vertical modes selected, only the lateral command bar will be visible. The command bars can be biased out of view by the flight director bars switch on either side of the glare shield. The switch on the left controls the command bars on the captain's EADI, and the switch on the right controls the command bars on the first officer's EADI. The flight director vertical modes consist of altitude select, altitude, vertical speed, and indicated airspeed. The flight director lateral modes consist of heading, navigation, and back course. These modes are the same modes as the autopilot modes. However, the flight director system also has a combined mode where the lateral and vertical guidance work together. These are the approach and the go-around modes. The modes are selected on the AFCS control panel. It should be noted that modes selected on the AFCS control panel apply to both the autopilot if it is engaged and the flight director. There are two modes that are not selectable through the AFCS control panel. These modes are the altitude select and the go-around modes. Altitude select is automatically armed. The altitude select is both an autopilot and flight director mode. The go-around mode is armed by pressing one of the go-around push buttons on the power levers. The go-around mode is a flight director mode only and is not applicable to autopilot operations. After pushing the go-around button, the lateral bars of the flight director will command the present heading of the aircraft, and the vertical bars will command a safe pitch attitude based on the flap setting and single engine performance. Altitude select is the only autopilot mode that stays active. Upon reaching a preset altitude, it will be captured as normal. Some modes require an arming and a capture phase before becoming the active mode. An example would be in the case where the active lateral mode is the heading mode and the crew is flying a heading to intercept an ILS. In this case, the crew would arm the approach mode by pressing the approach push button. This arms the system to capture the localizer and/or glide slope. Once established on the ILS, the AFCS active mode would be the approach mode. Armed modes are indicated on the third line of the advisory display unit. Armed modes are displayed in white. Captured modes are indicated on the fourth line of the advisory display unit. Captured modes are displayed in green. Armed, captured, and active modes are also displayed on the EADIs. The armed lateral mode is displayed in white on the top left-hand side of the EADI. The VOR, localizer, and back course modes have an armed status. For Omega-equipped aircraft, there is also an LNAV armed mode. The armed vertical mode is displayed in white on the top right-hand side of the EADI. The altitude and glide slope modes have an armed status. The other vertical modes do not have an arming phase. When a mode is in the capture phase, the associated armed indication on the EADI is removed. Instead, the mode is displayed in green followed by an asterisk. The entire indication is contained within a box. The box remains in view for the first 5 seconds of the capture phase. The asterisk remains in view as long as the mode is in the capture phase. Once a mode has been captured and is active, the asterisk is removed from view. Messages are displayed on the bottom right-hand side of the EADI. If the autopilot is engaged, this area will display an autopilot engaged message in green. If there's a caution message on the ADU, the EADI autopilot message will show an amber autopilot message to remind the crew to check the advisory display unit. The AFCS control panel is normally coupled to the captain's side at initial power-up. When the AFCS is coupled to one side, it uses data from the associated air data computer and symbol generator unit to determine the required guidance information. This guidance information is then displayed on both EADIs. The AFCS computer can be coupled to either the captain's or the first officer's side by pressing the couple push button on the AFCS control panel. Pressing this push button will alternately select the captain's and first officer's side. The side the AFCS computer is coupled to is indicated by a green arrow that is displayed in the left side of each EADI. The arrow will point in the direction of the coupling. In addition, the arrow adjacent to the couple push button will also indicate the direction of the coupling. If the coupling is changed while operating in the nav, back course, or approach modes, this will cause the automatic disengagement of that mode. For all other modes, the change in coupling will result in a smooth transition from one side to the other. A dual coupling mode occurs automatically when the localizer and glide slope are captured, provided both ILS receivers are tuned to the same ILS frequency. This dual coupling will be indicated by the illumination of both arrows on either side of the couple push button on the AFCS control panel. During a dual coupling, both navigation receivers will be coupled to the AFCS computer. The AFCS computer then uses the average value from both receivers to determine the guidance commands to fly the approach. If the approach mode is cancelled, the flight director will remain coupled to the side selected at the time the dual coupling occurred. In the event an excessive deviation is detected during a dual approach, or if Cat-2 engagement conditions are lost, the crew will be alerted by the illumination of the guidance light on the left side of the glare shield. If one sensor is failed on the selected coupled side, the AFCS can still be coupled, but the flight director mode that uses that failed sensor cannot be selected or engaged. All armed and engaged flight director modes can be cancelled by pressing the standby push button on the AFCS control panel. If the autopilot is engaged at the time the push button is pressed, the autopilot will automatically revert to the basic mode. The altitude select mode is automatically armed when the aircraft is climbing or descending towards a selected altitude. The selected altitude is set by rotating the altitude rotary switch on the first officer's altitude course panel. The selected altitude is then displayed on the advisory display unit. The altitude select mode goes through 3 distinct phases. These phases are the armed phase, the capture phase, and the altitude hold phase. In the altitude select mode, the crew can use vertical speed hold, IAS hold, or pitch hold to perform the climb or descent. Arming of the altitude select mode is indicated by a white altitude select arm message on the advisory display unit and the EADIs. When the aircraft approaches the selected altitude, the AFCS will transition to the altitude capture phase. When this occurs, the mode used to fly to the selected altitude is cancelled. The AFCS will provide guidance to capture the selected altitude. The altitude capture phase is indicated by an altitude select capture message on the ADU and a green altitude message on the EADI. Note that an asterisk will be placed after the altitude message on the EADI to indicate that the mode is capturing. The autopilot will automatically default to the pitch hold mode if the selected altitude is changed during the capture phase. Therefore, the AFCS mode used to capture the new altitude must be reselected on the AFCS control panel. Once the altitude has been captured, the altitude hold mode will engage and the altitude select capture mode will automatically disengage. The altitude hold mode is indicated by an altitude message on the ADU and a green altitude message on the EADIs. It should be noted that the altitude select and the altitude hold modes are automatically cancelled at glide slope capture if the approach mode is armed. The altitude hold mode can be engaged by selecting the altitude push button on the AFCS control panel. Selection of this mode automatically cancels all active flight director vertical modes. When the altitude hold mode is selected, the aircraft will round out the climb or descent to return and hold the altitude existing at the time the altitude hold mode was selected. the altitude hold mode is indicated by a green altitude message on both the ADU and both EADIs. The TCS system can be used to adjust the aircraft's altitude without canceling the altitude hold mode. Once the TCS button is released, the AFCS will provide the necessary guidance to maintain the new altitude. The aircraft can be placed in the vertical speed hold mode by pressing the vertical speed push button on the AFCS control panel. This action cancels any other active flight director vertical modes. The AFCS will provide the guidance commands required to maintain the vertical speed existing at the time the vertical speed push button was pressed. Engagement of the vertical speed mode is indicated on the ADU by the display of the vertical speed to maintain in hundreds of feet per minute. In addition, a green vertical speed message is displayed on both EADIs. The reference vertical speed can be changed by rotating the pitch trim wheel on the AFCS control panel. Rotating the wheel will maintain the aircraft in the vertical speed hold mode while changing the vertical speed reference value. The TCS system can also be used in the vertical speed hold mode to change the reference vertical speed. Any other vertical mode can be armed while operating in the vertical speed hold mode. Once the new mode is captured, the vertical speed hold mode will automatically disengage. The IAS hold mode is selected by pressing the IAS push button on the AFCS control panel. Action on this push button will disengage the active vertical mode. Once the IAS mode is selected, the AFCS will provide guidance to maintain the indicated airspeed existing at the time the IAS push button was pressed. This airspeed will be displayed in green on the ADU. In addition, a green IAS message is displayed on both EADIs. In the IAS hold mode, the pitch trim wheel is used to adjust the reference airspeed value. In addition, the TCS system can be used to maneuver the aircraft so as to achieve a new airspeed reference. Once the TCS button is released, the AFCS will use the airspeed existing at the time the button was released as the new indicated airspeed reference. Any other vertical mode can be armed while operating in the IAS hold mode. Once the new vertical mode is captured, the IAS hold mode will automatically disengage. The heading select mode is selected by pressing the heading push button on the AFCS control panel. This action will automatically override any active lateral mode. Once the heading select mode has been selected, the reference heading is changed by rotating the heading rotary knob. When the heading select mode is active, the ADU and both EADIs will display a green heading message. If the heading to follow is more than 180 degrees off the aircraft heading existing at the time the heading select mode is engaged, the AFCS will command a turn in the shortest direction. However, heading changes made after the heading select mode is engaged will cause the AFCS to command a turn in the direction of the heading change. In the heading select mode, the AFCS will use a maximum bank angle for the turn. This maximum bank angle is automatically set to 27 degrees when the system is initially powered up. The maximum bank angle can be changed by pressing the bank push button. Pressing this push button will change the bank angle from 27 degrees to 15 degrees or vice versa. If 15 degrees maximum bank is selected, the ADU will display a low message for bank. Any other lateral mode can be selected while operating in the heading select mode. The capture of any armed lateral mode will automatically disengage the heading select mode. The navigation mode is armed by pressing the nav push button on the AFCS control panel. This arms the AFCS system to capture the selected navigation source. This navigation source is displayed on the EHSI. The possible navigation sources are the VOR and the localizer. Click on the Nav push button to arm the VOR. If VOR navigation is selected, the ADU and EADI will display a white VOR message. The heading Select mode is used to capture the desired navigation source. At the time the selected VOR course is captured, the AFCS will transition to the VOR capture mode. This will be indicated by a VOR with an asterisk message on the ADU and the EADIs. The EADI message will be in a white box for the first 5 seconds of the VOR capture mode. Once the aircraft is on the selected VOR track, the ADU and EADIs will indicate a VOR message. When the aircraft approaches the VOR station, it will enter the zone of confusion where VOR station signals are unreliable. In this case, the AFCS will enter the overstation mode. In this mode, the AFCS will provide steering commands based on heading only. After station passage, the AFCS will recapture the selected VOR course. The localizer navigation mode is similar to the VOR mode, except that there is no overstation mode. The messages are replaced with a localizer message. The AFCS can be used to fly a back-course localizer approach. The back course is set up just like a localizer approach, except that the back course push button must be pressed. Selection of the back course mode cancels out glide slope capture. A back course is set up by dialing in the front course value. The ILS and go-around modes are common modes. The approach mode is armed by pressing the approach push button on the AFCS control panel. The go-around mode is entered by pressing the go-around button on either power lever. Pressing the approach push button on the AFCS control panel arms both the localizer and glide slope modes, provided an ILS frequency is selected on the coupled navigation receiver. When the approach mode is armed, the ADU will indicate a white localizer and glide slope message. The EADI will display a white localizer and glide slope message. When approach is armed, the crew can use any vertical mode and the heading select or heading hold mode to capture the localizer and glide slope. Capture of the localizer will automatically cancel the selected lateral mode. Localizer capture will be displayed on the ADU, and a green localizer with an asterisk will be displayed on the EADIs. Once the AFCS is tracking the localizer, the ADU and EADI will display a green localizer message. Note that the asterisk in the EADIs will be removed so as to indicate that the localizer capture phase is over and the ADU displays localizer track. The approach mode is called a common mode, since glide slope capture is not possible until the localizer has been captured. The capture of the glide slope will automatically disengage the vertical mode used to capture the glide slope. Once the glide slope has been captured, the ADU will display a green glide slope capture message, and the EADIs will also indicate a green glide slope message. Notice that the EADI glide slope messages have an asterisk after the message to indicate that the glide slope is being captured. Tracking of the glide slope by the AFCS is indicated by the removal of the asterisk after the glide slope message on both EADIs, and the ADU indicates glide slope track. Activation of the go-around mode will cancel out all active or armed flight director modes. Pressing the go-around button on either power lever will automatically disengage the autopilot, and the flight director will command a minimum safe pitch. In addition, the flight director will provide commands to maintain the heading existing at the time the go-around button was pressed. It is important that you understand that the go-around mode is a flight director mode only and cannot be flown using the autopilot. Engagement of the go-around mode is indicated by a go-around message on the ADU and a green go-around message on the EADIs. The go-around mode is cancelled by the selection of a different vertical mode, engagement of the TCS system, pushing the standby push button on the AFCS control panel or by engaging the autopilot. The AFCS provides an altitude alerting system to alert the crew that the aircraft is approaching or departing a selected altitude. The alert consists of a visual and aural alert. The visual alert consists of an amber light on the two altimeters. The aural alert consists of a C-chord tone. The altimeter altitude alert light illuminates when the aircraft is within 1,000 feet to 250 feet of the selected altitude. If you recall, the desired altitude is selected by the altitude rotary dial. The alert tone sounds when the aircraft enters the 1,000-foot point or exits the 250-foot point. The tone sounds for 0.75 seconds. This concludes the AFCS module.